This is problem number 13 on page 251. This is a rate times time equals distance problem. So as I've said more than a few times in class, I'll repeat myself here. The best way to work these problems is by developing a chart. You're going to see these problems over and over again in Algebra 2, SATs, and certainly in physics. So truly the best way to do these is by developing a chart here and filling in the blanks. And the equation, of course, is rate times time is equal to the distance in this chart. That is also rate times time is equal to distance. That also means that time is equal to, if you do the division here, the distance over the rate. It also means that the rate is equal to the distance over time. So you can move all those things around. So in this problem we have an object moving. It's a jet, and the jet is flying in one direction against a jet stream or against a headwind, and in the other direction he is flying with that advantage. So the problem tells us the following, that the speed of the jet is 750 kilometers an hour. Speed equals 750 kilometers per hour. Of course, that's a rate. Now, that's an airspeed, and that is without the effects of the wind. We are also told that the jet lifts off at its base and flew 800 kilometers against the jet stream, and then it returned to its base with the advantage of the jet stream. So look, the distance therefore is the same. It's 800 kilometers and 800 kilometers. So what are we trying to find here? Well, x, if you look at the problem, is the speed or rate of the jet stream, of the wind, which is the jet stream. Okay? So when he goes against this, his rate is going to be negatively impacted by the wind. So he's going to go 750. Now I'm not going to put in the units here, but you should work with them. I'm going to say 750 minus x. And when he comes back down, he's got a good tailwind, just like you guys tucking on the bottom of Inverness. He's going 750 plus the rate of the jet stream. All good with that? Now, we could solve this problem by entertaining another variable for the time, because we don't know the time that he is actually in the air. Either way, but we do know total time up and back is equal to 2 hours and 2 hours 24 minutes. I'm going to convert this immediately. Since the rate is in kilometers per hour, I'm going to convert 2 hours and 24 minutes to hours. So this is 2 hours and 24 over 60 minutes, which is 2.4 hours. So the total time that this is going on is 2.4 hours, up and back. So now let's go back to our chart and look about time. Time can be calculated by distance over rate. And the reason we're going to do that is so that we write our equation with one variable. So the time here is going to be 800 divided by 750 minus x. And time here is going to be 800 divided by 750 plus x. Now I'm going to set up an equation, and this equation is going to take into account the total time. This time up, this time back. So 800 over 750 minus x plus 800 over 750 plus x is going to be equal to this total time of 2.4 hours. I'm going to grab a clean sheet here and be right back so we can do the algebra. Here we are with a clean slate here, so we need to grind through in this algebra. And again, this is just the algebra that we have been doing previously in this chapter. So the common denominator is going to be a quadratic. So we're going to multiply the first term here by 750 plus x over 750 plus x plus 800 over 750 plus x times, I left myself a little space here, 750 minus x over 750 minus x. And of course that's all equal to 2.4 hours. Okay, now this is a quadratic, both top and bottom, which requires foiling. So this is 800, and I'm going to grab a different color here. This is 800 times that, 800 times that, 800 times this, 800 times this, and this foiled in the denominator. So our next step, or our next line doing that is as follows. Cool. Okay, so if I expand this, then we get 600,000 plus 800x plus 600,000 minus 800x. So those two terms cancel, and we're left with 1,200,000 all over 562,500 minus x squared, because these guys up here, difference of 2 squares. That is equal to 2.4 over 1 cross multiply, and we're left with 1,200 is equal to 1,350. I'm going to run sort of out of space here, minus 2.4x squared. That simplifies to negative 150,000 is equal to negative 2.4x squared. Negative 625,000 is equal to negative x squared. X is equal to 250, which is our answer.